Hello, Simulation Lab class. This Friday, I will not be able to be in the classroom with you, but I figured I'll leave you a recording and a little lab assignment for next week. It won't be due until the 13th of February. So what is this thing about an example with three customers? Well, today we're going to go ahead and observe a simulation system that has one server, and then we have customers. These are customers coming in. The first customer is being helped by the server, and the others will have to wait. There is a place here that says wait here, please. Wait behind the line, please. So uh, what are we interested in? This is this is not an assembly line. There's only one server. It is whatever the person is doing. Maybe they're helping you with your ID, or they need to sign off on something. The fact is that if you come in and the person is busy, uh, we'll wait for the person for the server to get available. What statistics do you think we need to calculate? Okay, what we're going to see is a series of events. And an event could be when a customer arrives. And what happens when you arrive? You either get service or join the queue, join the line. Either one of those two is going to happen. Once you get service, eventually you'll finish service, and that gives room for the next, that makes room for the next customer to be helped by the server. We're going to assume that customers arrive this way. They're arriving here. This is the next one. And there's virtually no time. By the time customer number one finishes and number two is helped, number one finishes, and in no time, number two will take their place here. So we're assuming there's no transition time between the two customers, the one leaving and the one that's arriving. Okay, in this simulation, like on Pro Model, when you do Pro Model, you realize that we have a discrete event simulation. What does that mean? That means that we move the clock only when an event takes place. What do we mean? Well, a customer arrives, that's an event, right? A customer arrives, that's an event. We move the clock, the customer gets service. The customer joins the queue and waits. The customer finishes service. So to give you an example of what an event is, suppose time is 10. So at time 10, customer 1 arrives. So the clock moves from time 0 to time 10, assuming it started at time 0. It is now time 10. Nothing happened between time 0 and time 10. At time 10 also, since there's nobody there, customer 1 starts service. Okay, nothing else happens until time 17 when customer 1 finishes service. So you go there at time 4, you happen to have a camera and look into the system at time 14. Well, nothing is happening. Nothing is happening. Okay, so not until time 17. At at time 23, customer 2 arrives and starts service, right? What happens if at time 24, customer 3 arrives? At time 24, customer 3 arrives. Well, customer 3 is going to have to join the queue, right? Because customer 2 is probably being helped. Anyway, let me give you an example. I'm going to give you a homework assignment with 8 customers for you to work in teams of 3 or 4. But I like to do a 3 customer example. I would want you to download a file that it's a PDF that reads more or less example with 3 customers. It's posted with this assignment. So if you download that file, please pause this thing until you get it handy so that you can work with me. Okay? So I'm gonna give you a minute to download it. I'm assuming you're pausing. And this is what we have. Okay? We have a snapshot. This is a snapshot of the system at what time? At time 0. Nobody's there. Okay, so what happens at time 0? The queue length is 0. The server is idle right now because nobody's there. You can see the server is doing nothing. There is nobody in the queue. This is the queue. This is the line. So I just wrote queue there. And we need to document what happens. What do we know about customer 1? A customer 1 arrived at time 0. Okay, so these frames that you see here, these cards, are snapshots of the system that you will get with me anytime the system moves. Okay, anytime something happens in the system. So let's track customer 1. Customer 1 just arrived, and I'm gonna switch to page 2. The arrival time was zero, and it's saying here that when the clock is 0, customer 1 begins service, and the server is now busy. Okay, so customer 1 starts service at time 0. Please notice that we don't know what time customer 1's service finishes. So customer 1 does not have an inter-arrival time, by the way. Remember, the first customer does not have an inter-arrival time. Oh, we know that customer time did not wait. How do we know that? Because customer 1 arrived and got service at the same time. It was instantaneous. We don't know the service time yet. Let's wait what happens with the next snapshot. When is the next snapshot? When is the next frame happening? Whenever something else happens. Two things may happen, and two things may happen. What's next? Well, one of two things. Either customer 1 finishes, we move the clock there, or Customer 2 arrives. So what happens if customer 2 arrives now? They're going to have to wait. Let's see what happens. Okay, take a look at this. It says here that when the clock is 8.4 seconds, customer 2 arrives. Let's remember that customer 1's arrival time was 0, no inter-arrival time. So what do we know right now? We know that customer 2 arrived at time 8.4. We don't know what time the service will start because customer 1's still there. That's why we see customer 2 waiting here. Okay, this is the waiting, this is the line. This is the waiting line. And where's customer 1? Customer 1 still being served here. But we do know the inter-arrival time, right? 8.4 seconds. That's 8.4 minus 0. 8.4 seconds later, we're here. Okay, all good? Let's see what happens next. I'm going to copy this table right here. Same information. I just copied the information we have. What's happening? It looks like customer 1 is still being helped and customer 3 is waiting. This is the waiting line. Okay, there's a wait here sign. So customer 3 just arrived at time 12.4. Okay, 12.4. We haven't started service. We can document the inter-arrival time already, right? 12.4 minus 8.4, that's exactly 4.0 seconds after that. Okay, all good. So let's see what happens next. Either customer 4 will arrive or maybe hopefully customer 1 will finish. Let's find out. Let me copy the info again. I'm just copying the info we had. Oh, the inter-arrival time is 4. Yeah, sorry. Let me erase this. I want to go ahead and write that down. And what does it say? Oh, customer 1 has completed service. What time is that? At time 45.2. Okay, so I'm gonna come to this cell here. And record this information, 45.2. And remember, we don't have an inter-arrival time. We did not have a wait time, okay? Well, maybe here, we do have a wait time of 0, okay? 0 minus 0 is 0, and the wait time is 0, but it counts. It is a statistic. The service time is 45.2, and the time in the system is calculated as the finishing time minus the arrival time. So for what is it for customer 1? Customer 1 finished at time 45.2. They're leaving right now, and they had arrived at time 0. So the time in the system is 45.2. Okay, all good. So with this information that customer 1 just completed service, we can go ahead and do this. Service ends. We probably already knew that the wait time was 0, But now we know that the service time was 45.2. And we can calculate the time in the system. What time were we leaving? What time did we finish? Minus the time of arrival. So we can just complete the entire row for the customer when the customer finishes their service. Okay. Remember what happens? Service is about to start for customer number 2. There we go. I'd like to show you customer number 2 happily being served. So the waiting line is only customer number 3. That's it. Okay. Oh, yeah. Let's copy the information that we had. 0, 0. Service ends 45.2. No inter-arrival time. Waiting time was 0. Service time was 45.2. Time in the system 45.2. Okay. This was 8.4 and 12.4. The inter-arrival time was 8.4 and 4. Now we know that service starts for customer number 2 at time 45.2. We don't know what time we finish, but we already know the wait time. The wait time for customer number 2, the wait time equals service starts minus arrival. So for customer number 2, it would be 45.2. This is 8, 6, 36.8, right? Yeah. So the wait time, the total wait time is 36.8 seconds. We don't know the service time at this point. All good? Okay, so what happened here is customer number 2 arrives. We can calculate, we can annotate now. We can take note of this customer's start time and wait time with that information. Okay, let's move on. Okay, 0, 0. What was it? 45.2. Nothing here, nothing here. 45.2 and time in the system 45.2, 8.4, 12.4, 45.2, and wait time, what was it? 36.8. Okay, the next event is could have been customer number 4, or it is the fact that customer 2 has just completed service. Okay, at what time? 64.9. Okay, so with that information, we can go ahead and annotate here 64, write down 64.9. Oh, we also had the inter-arrival time, right? 8.4 and 4. That was from before. I'm not adding this. That was on the table already. That should have been on the table. So what do we know? We know that the service time, can we calculate the service time? Yes, the service time was 64.9 and it had started at 45.2, almost 20 minutes, right? Yeah, almost 20 minutes, 19.7. Can we please calculate the time in the system. Okay, let's calculate the time in the system for this customer. What time is this? What time are we living at? 64.9. So time in the system for customer number 2 is the time we leave, 65.9, minus the arrival time, which was 8.4. That's 56.5. So this customer stayed 56 and a half seconds or minutes or whatever, seconds, right? Whatever this is. All good? All right. Next event, either customer number 4 comes in or customer number 3 finishes. Okay, so let's copy all this information onto the next page. 0045.2. Oh, this was a 0. Okay, this was 8.4. You will have a single table when you do your assignment. You don't have to copy everything again. And what else was there? 16.4. This is all info. Inter-arrival times, 36.8. Service time was 19.7. And time in the system, 56 and a half. And hey, if I make a mistake here, I'm doing things as I go, so just fix it up for me. It looks like customer 3 just began service at what time? 64.9. This is the same time as here, right? Because we're assuming the transition is negligible. So, okay, we have some good information there. Customer 3 begins, we write it down, and now let's see what happens. At time 78.6, customer 3 is finishing. So let me copy again, let me copy the information. Okay, we have copied the table and we're being told now that the third customer is finishing at time 78.6. Here's the 78.6. So customer 3 completes and exits. Maybe you can see customer 3 just leaving. This is customer 3 leaving the system. So what can we do with that information? The wait time, which the wait time is 64.9 minus 12.4, right? This is this customer waited 52.5 seconds to be helped. And then the service time was 78.6 minus 64.9. Maybe you can do this with Excel as opposed to doing it by hand like I'm doing it here. 13.7. And the time in the system, time of departure minus arrival time. And that will give you 662. Okay, I will give you 662. With that information, we can, I'm going to ask you to do this, but with that information, now that we have all those statistics, let's see if I can copy this to the next page, to next page. Copy. Oh. Paste. Okay, good. So with this information, we can calculate important statistics. For example, number of customers that we saw, 3, average inter-arrival time, well, that would be 8.4 plus 4 divided by 2. That would be 6.2, right? And you can do, you can just do the average of this column. You can also calculate the standard deviation of inter-arrival time, and that would be equals S standard deviation of this column. I want to just write here purple. Obviously not an Excel command, but please, you know what I'm referring to. Standard deviation of the purple column. I think we can also calculate valuable stats such as the average and standard deviation of wait time. And what are we talking about? Talking about the average of this column, right? If this was an Excel file, the average and standard deviation of this column, you can see that the average might be something like 30 minutes or so. The average of these three is 0, 37, and 52. I don't know. 30 or 40. No, 30, well, something along the lines of 30. Is it important? Yeah, service time. The same, right? Average and standard deviation of service time. What's the average service time so far? The average of 45, 19, and 13, whatever that is. So we're talking about the average of this column and the standard deviation of this column. And time in the system is also an important stat. Okay. We can also perhaps talk about the minimum queue size, which was 0, right? Happened a couple of times when nobody was there in the system. There's nobody there right now, right? This is the queue. This is the queue. But the maximum queue size, what's the maximum queue size? Here, two people, right? And I don't think we had more than two ever, if I remember correctly. The maximum queue size is equal to 2. The average queue size, I want your team to figure out how to calculate the average queue size, okay? The maximum waiting time, can we, oh yeah, we have that. It's 52, right? 52 and a half minutes. The maximum time in the system, 66, and so on and so forth, right? So we can do very interesting analysis. I would not advise you to conclude anything solid here just because we only have 3 customers, right? You need a bunch of customers. You can do this on Pro Model and get valuable statistics, not with only 3 by hand. Anyway, this is an explanation of what you need to do for next time. You're gonna get, you already got uh, an 8 customer simulation, so you need to do something similar to this, but except for the fact that you'll have 8 customers. All right, good wishes. See you around.